All right. Back to our game. Um, this is part 2 of instance rendering, right? Instance rendering. So why do we want that? We currently have lots of draw calls, and that's not very good. Now we're gonna have even more because we've introduced water. So right now, the water is drawn just like a regular cube. But the problem is that water comes with a twist. It's transparent. So being water transparent, that means that the order in which it gets drawn, it really makes a huge difference. So this is mostly happening because the order is not guaranteed. And you can see these artifacts. Well, well, well. So what's the plan for it? So the plan is that a chunk will not own a buffer anymore. It should be something like a sub-buffer. But first, I want to ask Jibity if you can suggest anything. So I'm using Vulkan to allocate vertex buffers to be drawn, but I want to dynamically allocate sub-allocate a single vertex buffer. Can I use VMA to do that? So allocate a big buffer once. Instead of creating a new VK buffer mapper mesh, you allocate one large with VMA, okay. Sub-allocate inside it. Bind vertex buffer, okay, that's fine. Dynamically allocating strategies. Okay, yeah, virtual block. That sounds... VMA also provide a higher level utility for sub-allocation inside a single buffer, VMA virtual block. This lets you manage sub-allocations with VMA's algorithm instead of rolling your own. Yes, this is exactly what I was looking for. Create a VMA virtual block of the same size. Use VMA virtual allocate and virtual free. Okay. Store offsets and use them in bind vertex. Yeah. That sounds like what I want to do. VMA doesn't directly sub-allocate inside a buffer for you. You either manage offsets manually, okay, that's fine. For convenience, this is a common pattern in Vulkan to reduce the number of buffers or buffer objects. But how much space will I even need? So how does that even work? Do you want me to show you a complete example with virtual blocks? Yes. Perfect. Let's go step by step with full example using VMA plus VMA virtual blocks. Okay, this is an allocation. Looks very much the same. Yeah, right. We need we still need the actual buffer. It's not like that's gone anywhere. Big buffer size, 64 megabytes. Wonder how much would I even need. Create a VMA virtual block for suballocation. This block represents your own allocator for offsets inside the buffer. Okay. So the problem is, where do I put that thing? Could it be a static object? Not very clean, to be honest. So create. So when it gets created, maybe I should start from when it actually gets created. So let me jump to the create function. Oh yeah, here it gets created. And it also needs to be freed. Well, the thing is that we already know everything about it before it even gets created, because we have the chunk data. So chunk and neighbors, we have the mesh generator. That generates a chunk data. Yeah, a chunk mesh actually. So we have the chunk mesh, which has indices and vertices. Well, indices are not useful anymore. You can probably change. We are more interested into the vertices. So this is roughly going to be just a vector of vertices in the end. And that's exactly what we really need. Yeah, so the last time I did quite a lot of moving things around. So the code now it's a bit smaller on the main application class. I basically halved the size of it. And I guess the chunk manager should be another class that I will move away once it's working. So for now, let me just go to chunk mesh, and chunk mesh doesn't really need any buffer. Okay, oh yeah, right. The next problem would be how to handle the water. So really what we need is it's a number of meshes. So when we generate a chunk, we don't only want it to be like the generator chunk mesh. Wait, what is even chunk mesh? Oh yeah, it's here on top. I'm gonna close the meshing function, which is in the way. And so the chunk mesh, it's a single mesh, which makes sense, but the meshing function might return more than one. That is a use case. And let's see how would that even work. I just closed it, so I have to reopen it. So this is where the meshing function is in action. And for every type, it just computes the neighboring. But it should also keep, should it keep like different meshes? Not really. We want layers, that's for sure. Yeah, we do want layers, but not for every type. And yeah, that's kind of something I need to dig through. I don't want it to make too complicated right now. Otherwise, it's gonna be harder for later. So let me grind this a little bit. So when we have the chunk that is generated, it could be made of different parts. And this is true for the water here. But what else could even happen? Like the terrain part is not really going to be different materials. Yeah, we don't really want each part of the terrain to be different. Only the water is going to be very different. And so we're talking about layers, where each layer behaves differently, and the water is gonna have it's gonna have a different shader, let's say. Yeah, that would make sense. Like enabling blending on the main draw, for example, that is not advisable because it's less efficient. So we want different pipelines as well. Okay. So we need something like layers. And we need to stick those layers in the generation too. But the data needs to be only one. Yeah, there is chunk data. Do we really need it to be split into no, we don't really need to be split into different, because they're not going to be overlapping anyway. So one block, it's either one type of or another type. Okay, so this is happening in the meshing function. Let me check if everything is clean. Oh, my main drive is filling up very quickly. I do have some dirty state here. Okay, now water. Yeah, let me save this state before moving on and remove that. Yeah, there's an outsider here. Let's get rid of this. We don't really need it. And this should be the water generation. Water generation. No, it's more like fix water generation. Yeah, yeah, this is just gonna be fixed water generation. In which I fixed the water generation meshing. And so now from the inside, you can still see the terrain. Before it was picking either one or the other one, and then everything else was blank underneath. And now it's like we are underwater. That's good. I'm gonna keep this on the side. Oops. Yeah, I cannot resize it properly. Whatever. Well, I guess I might start from the single vertex buffer. Yeah, let's start with this. So I'm gonna create a chunks buffer. Well, vertex buffer is fine. And then I'm gonna allocate all the space I'm gonna need. Yeah, the staging bit is going to be something. Yeah, how much staging do we even need? Create a staging, and then the staging is gonna update. Yeah, That should be fine. I think it's gonna be fine. So we need to create the vertex. Okay, we're gonna make a buffer and then create staging. So what is the staging? So how much data do we need for upload? Like what is the maximum number of vertices? That will be dependent on the resolution. It's not gonna be a lot. So that is like so the chunk size is 8 right now, and that would be 8 cube. That's the number of cubes, potential cubes, times 6, which is the number of faces, times 2, which is the polygons for each one, and this is the maximum amount that we need. Okay, I'm gonna say that's good. What? Can you copy this? Well, 6,000. Oh no, this is the, okay, this is the buffer actually. Now the buffer, for the buffer, I want to create an amount that's based on megabytes. Well, there's going to be 6K by, I don't know, with 1,000 it's gonna be 6 megabytes. Yeah, that's not a lot. But oh yeah, need to multiply by the size of the vertex input. This is megabytes. So that's 64 megs. Mm-hmm. 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 For create staging. What's the staging? Say 6,000. Yeah, that should be a good number. And if it fails, well, nothing's really gonna happen. Let's just leave it at that. We have nothing to update. We don't need to destroy anything, so this one is gonna be commented out. Now, yeah, instead of the vertex buffer, you're probably gonna need the suballocation. And when it gets created, you won't have a vertex count anymore. Neither the scripter set index, this one probably yes. This node, and this goes, and you will need something else, which is going to be provided somewhere here. Chunks. Yeah, but wait. So we have the vertex buffer, which is a buffer, but buffer doesn't really have a suballocations. I maybe need to update the buffer class. Let's go and check that out. So where's GPT? Create a big vertex buffer, and that's fine. And then create a VMA virtual block for suballocation. So how does a virtual block work? Suballocate. Okay, so we have the buffer, and I can just say suballocate and copy. Would that work? Well, I guess the copy needs to be done in a different way. Maybe I can have staging buffers, like a pool of staging buffers. That would work. Or I can just do one by one right now. That's what I was doing anyway. So one block update per frame, and that is good enough. So the suballocate function, I have no idea what it's going to return. Suballocate. What does it suballocate? So the size. Yeah, I just need the size, which is going to be a VK device size. Most VK device size. Usage? No, I don't need usage. Why would you need usage for? So this is all I need to create a suballocation. And we get a virtual block. Virtual block. Maybe this can return directly the VMA virtual block. And does it fail? And if it fails, we should do something. So if VK result if this isn't success, okay, so maybe we should return an optional. Okay, so this is going to be an optional, and if it fails, otherwise it's gonna return the virtual block, which I'm gonna rename. This will be block info, and this is virtual block. If it fails, we'll return the null option, otherwise we'll return the block. And this is this this can't be const, can it? Like, it's technically not modifying anything in the class, even though it's acting on the memory. VMA virtual block. So this can be made const. Oh wait, there is a creation flag. Linear algorithm. Create flags. Yeah, we don't virtual allocate. Suballocate space for a mesh. Wait, what? Isn't that enough? Create a big vertex buffer, and we did that. These blocks represent your own allocation for offset inside the buffer. Suballocate space for a mesh. When you load or create mesh, ask the virtual block for a region. VMA virtual allocation. What is virtual allocation? Upload the vertex buffer. Okay, I'm not following this. There is 2 guys watching right now. Oh, great. Might be only 1 now. Anyone's free to watch. How are you doing, Advaith? What brings you here? You interested in graphics programming, game development? To create a virtual block. And we understand that suballocate space for a mesh. This I don't understand. Destroy virtual block. So summary, okay. Create buffer allocates the physical GPU buffer. That is fine, okay. Create virtual block, give you suballocation system inside that buffer, okay. VMA virtual allocate, manage vertex region dynamically. But is it required? You should use Bevy. Why would I do that? I mean, Bevy is not gonna solve the problem that I have anyway. So it's not gonna give me the game that I need. I have to do it anyway. Also, I already have an API. It's Volcar. I can use it directly. Does Bevy even support VR? Bevy, can you do MetaQuest? How is it spelled? Bevy? I don't see much. That doesn't seem to be UI interface. Yeah, there's no virtual reality. VR. There's not even any VR. Baby VR. OpenXR. Virtual reality rendering. Yeah, I don't feel like it works in VR. So yeah, whatever. VMA. Binding during draw. Freeing suballocation. VMA virtual free. So virtual 3 and create virtual block. Yeah, maybe I should go to the official documentation. How to create virtual block. So making, okay. When AI doesn't make any sense, it's always a good idea to go to the real documentation. So creating a virtual block. To use this functionality, there is no main allocator object. You don't need to have a VMA allocator object created. All you need to do is to create a separate VMA virtual block. Block info. Okay, I see now. There is actually no VMA. So this isn't creating virtual block info. Ah, okay. Okay, it creates a block, whatever it is. Then a VMA virtual allocation object contains internal data structure that keeps track of the free and occupied region. VMA virtual block. Internal data structure that keeps track of free and occupied regions of the same using the same code as the main VMA, Vulkan Memory Allocator. Similar to VMA allocation for standard GPU allocation, there is VMA virtual allocation type that represent an opaque handle to an allocation within the virtual block. Virtual block. Okay. So the virtual block is not actually the block that I'm going to be using, which is confusing, okay? VMA virtual allocation create info. So the block How big is the block then? Okay, oh, so the block is actually the size. But where does the data get into play? Making virtual allocations. There is a VMA virtual allocation. Okay, in order to make such allocation, fill in the VMA virtual allocation create info. Call virtual allocate. Get the VMA virtual allocation object that represents the allocation. You can also receive a VK device size offset that was assigned to the allocation. Okay. VMA virtual allocation create info. So the buffer really have nothing to do with all of this. So the virtual block is, okay, it's a parallel metadata. So it's not allocating inside the VK buffer. Yeah, of course it doesn't really have anything associated to that, but this guy here needs to be on top then. Usage sub allocate. Well, maybe it's not, yeah, it doesn't need to be created every time. And what is it, by the way? It's just a handle. So it's a pointer. Yeah, it's a pointer. So we can define it as a VK. It's probably going to be a VK null handle. And here we can check whether we already have that. If the virtual block is null, don't have the virtual block, then we need to create it. And this guy it's got size and the flags. We don't need the flags, but the size, yes. So the size gonna be const dot size. Yeah. We create the virtual block, and then inside the virtual block. So this is not going to be a virtual block. Needless to say that the official documentation is much clearer than any AI slop generated. So the size is not going to be the size of our suballocation, but rather the full size of the buffer. So that's the full size. And then we have, I'm gonna put it on the side and maybe close a few files. VMA virtual allocation is the thing that we need to return. What does it contain? Oh, it's a handle. So we get allocation and offset. Okay. We need to keep track of both of them. Also, how do we release it otherwise? Yeah, I feel like we need a struct at this point. Which is a buffer suballocation. And it contains the two objects that we have here, which are the allocation object and the offset, which is what is then generated. And we can return that. So again, the allocation size is gonna be size. And I feel like I can just put that in here. Oh man. It's gonna be const. And here we want to use, no, actually, I can just leave them like this. And we're gonna check for errors. If const vk result. What is block? The block is the virtual block. Then it's gonna allocate. You need to check for the result. If it's a failure, we can do that. Or maybe we can even add a message error. And the same here. Then we can finally return the allocation and the offset. That's wrong. Stood optional. So that's gonna be a buffer suballocation. Okay. Woo, that should be it. So suballocate will do that. Free, we also need to take care of freeing. Create virtual block, but wait. Okay, so this is really not going to touch the buffer anyway. So the buffer is kind of parallel to this whole suballocation thing. And I wonder if we can do the same with suballocating into the staging buffer. That would be nice. Suballocating the staging buffer. Create staging buffer. So that can be an update command. I guess I can do that in a second. At the second time. YouTube is not receiving enough. Enough what? Enough video to maintain a smooth. Oh. Is it so bad? Yeah, I feel like it's doing good. Weird. Is this stream so bad? Open Studio. But I don't have any dropped frames. I don't know why it's complaining. Looks good enough to me. Whoa, we have a sublocation. Sub free. How do I do that? Free. Yeah, I think I just go free. Or destroy. Destroy. Well, destroy should also destroy the suballocation thing. Virtual 3. Yeah, VMA destroy the block. Destroy staging. So if we have a buffer, I'll do the buffer thing. If we have a virtual block, then we gotta do the block thing. Virtual block, that's it. No need to make up for parameters that don't exist. Ooh, set virtual allocation user data. Yeah, I don't think I need that. Okay, so that's suballoc, and then we can make sub free. And sub free is gonna get a buffer suballocation suballoc. We're gonna check if we actually have a virtual block. And then we call the free function. And that's it. This is no discard. And boom. I think we have it all. Now, back to the main app. So the main app doesn't have, oh yeah, it does have the frame context. So we can even do the update, I think. Where does the update, oh wait. Now that I'm thinking about it, what happened here? Oh, we didn't execute immediate. That's so bad. That's why that's why I was getting so many hiccups, because it was trying to run an immediate function which is blocking during the command buffer creation. Okay, that is something that we're gonna fix now. Because since we have the frame context, we can also do the suballocation, but first I need to get the suballocation into the chunk. So instead of having a buffer, you're gonna have a VK buffer suballocation, and that's gonna be the vertex buffer, your local copy of the vertex buffer. And what's wrong is initialized. Okay, whatever. But this also needs to be initialized. So this is a VK null handle, and the offset's gonna be 0. VMA's virtual blocks uses 2 levels segregated fit allocator, which is a bit overkill for a staging buffer. Usually a staging buffer pattern will in a linear allocation. A virtual block is preferred for persistent GPU memory like virtuals. Okay. So let me try to understand. Is it gonna be so complicated that so complex that, well, because I mean, if I having multiple draw calls or rolling my own, I'm not sure that's gonna be better than using VMA suballocator anyway. And it's also not like it's not like there is a lot of allocations anyway. The number of allocations that I'm gonna have is gonna be just the number of chunks around the center, which is somewhat around, I don't know, let's say we're gonna have how many I think maybe 10 cube. That's just not like a lot of allocations anywhere. Yeah, but maybe having a pool is also a good idea. Yeah, who knows? I'll see what happens. It's simple enough. I feel like it's simple enough for now. So I would rather do incremental updates. What was I doing? So chunks. So it's just that staging buffer is usually populated as you set up your data to upload. So you just bump the pointer forward for each suballocation. Yeah, I mean, I'm not really using it for staging data right now. I was thinking about it for the next step. I'm basically updating one chunk at a time, so that was just much simpler to visualize the update in progress, and having that immediate it really makes sense that everything was going a bit slower and popping. because the chunks are not that big even. Like each chunk is something like 8 cube. But on the Quest, yeah, the Quest is a very low end device anyway. But yeah, thanks for the heads up. That's I haven't used VMA in such a way that I have explored more of these utilities. So when I get the chunk, I need to suballocate. Vertex buffer. And I'm gonna need chunk data. Vertices, size. Well, not just the size, there's also the vertex type. I think I can do size in bytes. Can I do that? Byte size? No, this one only has size. What is this? Garbage. Chunk mesh. So wait, where this is defined? It's a measure. Well, yeah, I'm just gonna hardcode it. That I shouldn't be hardcoding this value, but here's another shortcut. So the vertex, the size of the vertex input size of what's wrong here? And use the result of a function, no discard. Yeah, of course. Buffer? Yeah, let's call it buffer. So are you working on any project, SciCode? Chunk, do I really need to pass the chunk data anyway? It doesn't seem like it's gonna use it. I might just create the chunk data and then start a copy. Yeah, let's just start a copy. And I might even say that, how do you do the copy, it's going to be something like this: update. So the vertex buffer, and this is going to use the frame context command, and it will be a chunk data vertices. Yeah, that should work. We do the update, and then the create function here doesn't need, it doesn't need any of these. Yeah, this is at this point being reduced to a dummy structure. Yeah, it doesn't have much. Upload the data, no need to upload anymore. Just remember sector, color, set index, and the buffer. Okay, that's it. Now discard. From here, I need the VK device size buffer offset. That's gonna return the vertex buffer offset. And I'll need this one later. So now that we have set index, yeah, also the set should be suballocated from a single array. So in the end, we can make everything automated. And that's a buffer. Wait, what? What's the problem? Oh yeah. Yeah, that's an optional. Oh yeah, that's an optional. I'm gonna get the value, but first let's check if buffer is valid. If it's not valid, then I guess we'll just break. And this should, okay, this should be checked earlier, I think. So if the chunk data is empty, if the chunk, what are you doing? If the chunk data dot vertices is empty, then just keep going. And this is const. Yeah, that can be const. And if there's no allocation, We also break. Yeah, we just break at that point. That's it. I feel like we do a break here. Yeah, we do a break anyway. If it's successful, we do a break. Now, what is the difference between these two? It's that the chunk is not generated. So same check, and then same allocation and update. Oh yeah, the delete buffer. Yeah, right. We need to delete the buffer. No more, because the old chunks buffer, they need to be deallocated instead. Vertex buffer. We have a sub-free instead. And that will be the chunk no discard, and no, not this thing. So that will be VMA, or maybe I can just return the VK buffer allocation buffer. Yeah. Consref. So that will be chunk buffer. And yeah, that's it. We get the buffer. Now that's pretty much it. Yeah. So we did the sub allocation. Now we create another allocation. If the allocation fails, that's it. Well, first we create a new chunk, and then we check if it failed. Otherwise, it's gonna try to use the old suballocation and everything crashes. The doom. Okay, everything else is almost the same. We have the chunk, just need to update it and then break. Okay. What's wrong here? So if chunk size is the redundant else. Okay. Why? Why is this a redundant check? Anyway, the last bit I need to update is the draw function. So for each chunk, we check if the chunk, what do we check? So are we creating chunks that, So if this has data, do we create chunks anyway? is a bit different than before because we had chunks with no data. Here we are checking the data earlier. So do we need empty chunks? Is this gonna try to generate forever then? So if we don't have data, then we create the chunk, or we don't create the chunk. Kind of makes sense to not create the chunk anyway. So we should not be in the case where a chunk doesn't have data. Or do we? Let's see. Yeah, it shouldn't happen. Well, we will notice if it happens. So, vertex buffer. So the vertex buffer that we need is always the same. That's going to be vertex buffer. Wait, what's wrong? Oh yeah, it's an object. Oh, the vertex count. Yeah, that we forgot. We forgot about the vertex count. That's the buffer. And here we need the vertex count. Yeah, vertex count, sector, set index. Chunk. Chunk index. Wait, what? Chunk indices. Where does chunk indices come from? Chunk indices. What is chunk indices? I forgot. And place. Okay, this should be the number of vertices. And we have also this data, which is the last bit. Vertex count. Oh yeah, the function is missing. What is that? Vertex count. Yes, this makes much more sense. And you should have a vertex count now. Vertex count. Is it gonna build? I hope it's gonna build. Is it gonna run? Yeah, I feel a bit less comfortable with that. Uh, this is interesting. I like it. I like what's well, it's not crashing. What's happening? So whenever there is a change, what are you doing? What are you doing? Uh, I don't know if I'm happy about it or not. Why is it so slow? Looks laggy. What are you doing? Let me break into it. Oops. Also, that doesn't sound very good. Retry. What happened? Some virtual allocations were not freed before destruction of this virtual block. Okay. Is that a problem? I mean, can you just free them all? Oh, well, no, because they, okay, I see now. Because they are allocating data somewhere. Okay, that makes sense. But oh, wait. Why am I doing the offset 0? Yeah, that was the whole purpose of using the sub allocation to get the offset right. And what you do, you don't get the offset. So buffer dot, wait, no. The chunk. Yeah, chunk dot buffer offset. Okay. This should be already better. What is chunk? What is wrong with you? Ah, it's not const expr. Well, of course it's not. Oh, I'm so close. No. You shouldn't do that. What is happening? Oh, I didn't put the offset. That's why. You little dumb. You didn't put the offset when doing the upload. So the upload that happens up here, update command, you forgot the offset. So that's a span. And then the last piece of data is the buffer dot of set value, maybe the value dot offset. This makes much more sense now, but not like that. And like this. And what's wrong with it? Span of the vertices. Yeah, what's wrong with you? Class span. Okay, but what's the problem? Why are you highlighting it? So that's just a span. What's wrong with it? So update command wants a span. It doesn't have. Okay, I see. Let's go to any of these. So it was matching against a span of data, but then I didn't provide the offset. Okay. I guess that's fair. You should be happy now. Still not? Oh, okay, it's gone. Great. It compiled. Why are you doing this? Why are you doing that? What's missing? What is missing? You got the offset, so what's wrong? Buffer update. Oh, yeah, of course. I forgot to also put it here. My bad. Oh, this is getting boring. Oh, yeah, of course. Of course. What's wrong now? Alright, it's time to stop and see what is happening. So we're gonna generate the chunk size is less than chunk count. Okay, so we have new chunks and we need 700 chunks. Okay, we start with the generated data, then it doesn't have vertices and we don't generate chunks. We have a chunk count and we don't stop until we reach that. That means that unfortunately it's gonna try generating. Oh, okay, that was so slow. That's why it is so slow, because it's gonna try to generate chunks continuously. And we don't want that. So once the data is generated, then we create a chunk and then we check. So the chunk will always be generated And it also needs chunk. Yeah, it needs a sector. It definitely needs a sector. And it is created. It can be empty. So it has a size and value for the buffer. And it can have no buffer. Why? Yeah, why not? It could have no buffer. So that wouldn't be wrong. And buffer is just, yeah, that is not an error. So chunk is generated. We don't need to stop here, but also we have two different versions at this point. We need to stop it if the chunk data the vertices is not empty, then we create a buffer and we do everything by the book. And chunk is already generated, no need to make a new one. Otherwise, well, just create 0 and then an empty allocation. Okay, and the same goes here. Well, not really. I mean, if we can allocate the buffer, then it's fine. I mean, why wouldn't be? Well, wouldn't we be able to allocate the buffer? Yeah. But for the sake of safety, I'm gonna say if we have buffer, we do that. Otherwise, same as here. Whoops. And that. We just create an empty one. Oh boy, this is getting a bit complicated now. So I guess we can just ignore this bit for now. And if 0, yeah, that's not gonna happen. So let's see. I didn't check. Yeah, I didn't do the check. I should do the check before drawing. Hmm. So let's skip if chunk the vertex count is 0, then we're gonna skip that. And I want to break here. Let's break right here to see what's happening. We have step over F8. Okay, we generate a chunk. Generate a chunk. Hey, what? What happened? What's happening? VK create cannot open shader validation. Okay, yeah, I don't really care about that. Ooh, weird. Not sure what happened there. Okay, let's try again. Okay, it doesn't have vertices. So we create an empty chunk. Let's go to when we have actual vertices. Yeah, go away. And that is just empty. And that was the last one. Yeah, the only one. Let's try again. We generate a new chunk. And it's also empty. I don't want to stop there anymore, but instead stop here. Play it back. And this also, I want to stop it when it's doing some useful work. And okay, we finally get some data. So this is the allocation. Its offset is 0. That's good. The vertices, and then save the whole value. It doesn't have a size, does it? Yeah, it doesn't come with a size. I must keep track of the size. Vertices, yeah, that should be right. I mean, the vertices size, and then it's a vertex input. Okay, we got something finally, and the buffer, it's that buffer. The offset's gonna be 0. Yep. Buffer data. And the chunk vertex count. Yeah, we have also that. Size, height, descriptor. This is a bit high. Is the descriptor coming through? I'm not sure we did a proper update of the descriptors. Yeah, probably. I mean, this happened here. Chunk.size +3. Okay. All good. So far, so good. Now the next have an... Okay, we got an offset. We do the create. Oh no! Wait. I should have stopped here. Yeah, I wanted to see what happens in the update. Because it did an update, but with what? So that's the span of data, and it gets an offset. But the offset... And the offset is wrong. Or is it? Let's go to the update. That's the offset in bytes. Data size in bytes, and then the offset. Wait, where is the offset? Is it ever used? It's not even used. Ah, that's why. It is not used. Source offset. Also, is it the source of? No, yeah, it can't be the source offset. It's the destination offset. Is it? Or... Yeah, it's a destination because the staging always starts at 0. So that's gonna be the offset. Okay. I guess this should be the one that makes it work. Because if the offset was always 0, that's why it was flickering around the first chunk. Good. That looks good. And that looks awesome. Kind of. There are so many holes. What happened here? That is not too awesome though. That's not the greatest result. So I guess that's because I need to update also this function here. Yeah, let me simplify this guy here. I mean, if this happens, I guess I will think about it another time. And this is a const object. So this checks whether this is less than chunks count, and this checks whether it's empty. If it's not empty, chunk indices is not empty. Yeah, I don't understand why this would be redundant. Ah, because of the break. Okay. So again, here the same. We remove that check. Then we have the chunk index, the set index, the color, and we get the chunk. We get the chunk. We free its buffer. And then after we get the actual chunk, can replace this whole bit. And we only stop until we generate an actual chunk, not empty chunk. Okay, so if this happens, then it's gonna break. Otherwise, yeah, this kind of makes sense now. And the same goes with this one. Um, Something's wrong. Oh yeah. No. Mm-mm. All right. I guess it's time for dinner. Um, we'll continue this later. Bye. Bye bye.